Hello everyone. Problem of the day question was array duplicates. Given an array of size n containing elements from the range 1 to n, and each element appears at most twice. Return an array of all the integers that appears twice. Note, you can return the elements in any order, but the driver code will print them in a sorted order. The core idea is we use the array itself as a tracking system by temporarily modifying values. Since all numbers are between 1 and n, we can use their positions in the array to mark which members we have seen before. Here is my code. Let me compile and run. Compilation completed. Use the array as a visit tracker. Instead of creating a separate data structure to track counts, we will temporarily modify the array itself. Since all values are positive initially, we can mark a number as visitor by making the value as its corresponding index negative. Map values to positions. For any number h between 1 and n, it belongs at position x minus 1, since arrays are 0 indexed. Example, number 3 belongs at index 2. First visit is a second visit logic. First time seeing a number, the value is at its position will be positive. We mark it as visited, making it negative. Second time seeing a number, the value at its position will already be negative. This tells us we have found a duplicate. Handle negative values during iteration. As we traverse the array, some values might already be negative because we marked them. We use math data to always get the original positive value when calculating positions. Why it works? Each number acts like a pointer to its own home position. If we visit that home and find it already marked negative, then someone else will the same value must have been there before us. Metaphor. Imagine a parking lot with numbered spots 1 through n. Each car has a number matching a spot when a car arrives. If its spot is empty, positive, it parks and marks the spot occupied, makes it negative. If its spot is already marked occupied, negative, we know another identical car already parked there. It's a duplicate. Performance analysis. Time complexity is O of n. We make exactly one pass through the array. Each operation, calculating index, checking value, marking, takes constant time. Even though we might modify the array, we only touch each element once. Spare complexity is O of 1 auxiliary space. We don't create any additional data structures that grow with the input size. We only use a fixed number of variables, I, position, n. The result array is required output, not counted as extra space. We reuse the input array as our tracking system. Memory efficiency note. While the algorithm modifies the input array, it's temporary. The array could be restored if needed, but the problem doesn't require it. Why this is efficient? 1. No hash maps or sets. Avoids O of n extra memory. 2. Single pass. Optimal time complexity. 3. Mathematical mapping. Uses array indices as natural buckets. 4. Sign-based marking. Simple and reversible. Trade-off. Extremely memory efficient. Fast and simple implementation. Modifies input. Though this is usually acceptable, requires understanding of index value relationship. Key insight to remember. The position of a number tells us about the number itself. By using the array indices to track which numbers we have seen, we turn practical position into temporal information about visits. Let me submit the code. Problem solved successfully. My current stake is 374 days. Let me push the code to the GitHub. The commit message is add solution for finding duplicates in an array with examples and complexity analysis. Let me commit and push. The code is pushed to the GitHub. You can grab the code in the description. Thank you for watching this video. Like and subscribe to Newscraft Studio for more awesome content.